Director of Outreach for the College of Engineering at Northern Illinois University, and we're going to show you a few robots tonight. Most people, when they think of robots, think of something like this, or maybe something that looks like a maid out of the George Jetson show, okay? But we're going to show you a couple of other versions of robots, and we're going to start with our robotics club, and they're going to tell you about the robot that they have, okay? And we're going to start with Victoria. Victoria, come on in close.
Hi, my name is Victoria, and I'm here with Dari and Tim, and we are here to tell you more about the NIU Robotics Club. So, as you might know, there's a lot of different types of robots out there. You have robots that can walk, those are called humanoid robots. There are robots that drive on land, that fly in the sky and swim in the water. And all of those robots are used for different purposes. For the Robotics Club, we like to make robots for fun and to compete in a competition called MRDC. MRDC stands for Midwestern Robotics Design Competition. And that competition normally takes place every March every year, but we haven't been able to go for the past 2 years because of the pandemic. So we've been working really hard to get our robots in a good shape for next year.
We're going to show you some slides.
Alright, so if you can see the course, in the competition there are different goals and or like baskets that you score points in, and the robot that we use for this competition will pick up, I think we use balls in this like little pit, like a foam ball, and we will take, you can either pick up or launch like the ball or whatever we're using for this instance, game pieces, and we put them in the baskets, and the more points you get, the more objects you pick up and put in your basket or your goal, the more points you get, and that's how you win the competition. At the end of the typical competition where you score points in this course, there is a demolition round, and we will tell you a little bit more about our demolition robot a little bit later on in our presentation. And so the first robot I would like to talk to you guys about is our Quinn robot, and that is our Quadcopter, and we will show you what the Quadcopter is. Can you guys see the Quadcopter all right?
Go ahead.
Okay, so this is Quinn. This is our Quadcopter. It's called a Quadcopter because it's like a helicopter, and it's like a helicopter, and it has 4 rotors, and these are the rotors are these outside parts. So the Quadcopter Quinn, the abbreviation is Northern Illinois University Quadcopter, although it's backwards. So you have Quadcopter University Illinois Northern Quinn. We competed with Quinn in MRDC in 2018, and this robot took first place in the competition. Right now, Quinn is going under some construction, so we don't have the wheels, but typically Quinn will have wheels on the bottom so it could drive on the ground, and then it has propellers on the top so it'll fly in the air. I believe, I wasn't there for the 2018 competition, but I believe it flew through a hoop during the competition and scored points through that. And then, I don't know if any of you have flown a drone or an RC plane. The remote control for this robot is exactly like that. I will show you what it looks like. This is a controller that is used to fly Quinn. If you've used one of these before, it's fairly simple. You move the propellers with the little levers back and forth, up and down, and then I believe this robot had an arm attached to it, so we have a little arm switch. And yeah, this is our Quinn robot. We're working on getting it back up to speed for next time around. So if you catch us around in the future, hopefully we'll have this thing put together and we'll give you a demonstration of how it flies. Okay, and then our next robot that we will talk about is Nerf. And then we'll have our member, or our officer, talk about it.
Alright, so this is Nerf. It was like it's our ground bot, the main bot that was used in the competition. It won the last time that we actually competed. So it drives like a tank, so one side's controlled and so is the other one. They're independent of each other. And it also has this scoop there, and it would drop down to scoop up the balls to score in like a basketball sort of thing. And also in the competition it had to drive over like rough terrain over a bridge, and you get points from doing that multiple times. It also had a Simon Says to get the balls out to be shot. So it did have a spatula sort of attachment onto the side, but we had to take it off because it's easier to move around that way. And it would just be controlled through a controller like an Xbox controller. And so we have that connected, and then the way that this functions is it would collect the balls by this spinning and then bring them up here and then being shot out through that. Should we demonstrate it?
So we got some nice fancy lights on our robot. We got some nice red lights underneath, so you can see the wheels. It adds some flair to our robot.
Alright, so we're going to demonstrate it back in this little area. So you can drive forward or backwards. Okay, so as you can see, it's pretty loud, but that is how it. Okay, so yeah, it's pretty loud, and it shot the ball. We were going to have like a laser pointer attached to it, but that wasn't allowed in the competition for whatever reason, for accuracy. So we just kind of like lined it up as best as we could and would shoot it into the basketball hoops. And yeah.
Nerf, and then next we have Dari explaining David.
Hey, so for David is our newest bot, and for this bot, it actually just started in production, so we don't have it built yet. But what we can imagine is we're going to be taking something similar to Nerf here, right? So just a box with wheels on the side and it drives, but we're going to put ramps on both sides. And the purpose of this bot is it's going to be going into the demolition round. And the demolition round, as you can probably guess, is all about destruction, right? So it's just robots slamming into each other, causing as much mayhem as possible. And yeah, for our bot, our tactic essentially is just to use those ramps, have it go super fast. We think it's probably going to be going somewhere around 40 miles an hour, which, you know, that's basically what cars are doing on the streets, right? So you can imagine a 40-mile-an-hour wedge just ramming into other robots. They're going to be going flying, and that's basically all it is. So the name for this bot, as I think I said, was David. The reason we called it David is actually because there's another bot in the demo round that's been in there for a few years, and that bot's called Goliath. So if any of you have heard of the story of David and Goliath, that's what we're kind of going for here. So as I said, we don't have the bot for you here. It's in production right now, but we do have a video of BattleBots. If you guys have ever heard of BattleBots, it's a show, I think it used to be on Discovery. I think it switched channels now. But it's basically a demolition round like what we're doing, where bots go head to head and try and destroy each other. So if we can pull up the video over here, we can take a look at that and you guys can see what we're going for. Alright.
There you go.
Yeah, I think you can see that there. So there's no sound for this, unfortunately, but this is a preview of what's going on.
Just an idea of what you future engineers can do once you get to NIU. What is this doing?
So right now it's actually looking for a specific color, more pink. I chose pink for just because it's the most bright color out there and it's easier to classify for a computer to understand. Now the one massive problem regarding tracking a color and following it is that there's other colors out in the environment, and unless it's really dependent on light. It's actually heavily dependent on light. So if you have light, it's not very bright, it's going to be harder to see. Or if it's too bright, then other colors are kind of wash in together. So now to fix this problem, you guys probably have not seen this, or you guys may have. So this is more of a QR code. So a computer is more capable of recognizing patterns rather than colors. So patterns can hold IDs in them. So a basic, you guys have QR codes on your produce. So if you buy like some vegetables or any canned goods, you're gonna have something like this or a barcode. And that is a lot easier for a computer to understand than a color. So I'll demonstrate this, and it's a lot more reliable. So right now, the robot's not moving. I guess I'll to follow me, go back.
So in a search and rescue scenario, what would this robot actually be doing? What would its purpose be?
So in search and rescue mainly, it really benefits the human to have more eyes in the environment. And the way we apply these robots is, yes, you could have a lot more humans in there, but then you kind of increase the risk of life being, individuals being hurt. Firefighters also have to go through a lot of physical strain. They have a lot of weight on their backs and everything. So it's like about 7,500 pounds of gear that they have. And in this way, we can actually apply a robot that's, it's not very expensive. I mean, this one is just a modified Roomba, which you guys probably have at home. Which is really nice. And you could just deploy multiple of these and then have, in this case, a code on the back of a firefighter, and it can know what it's tracking, and then at the same time look for any possible humans or anything that's lost in there in the building. So,
excellent. Thank you, sir.